And so this lesson really is just a continuation of what we did yesterday, and we're going to do a lot of integrating with natural log, but we're going to do it in the context of problems that we've already seen, okay? This lesson shouldn't be too long, and feel free to work ahead at any point if the one we're on is easy for you. Okay, we're actually going to skip example 1 because we did work on some of those integrating with bounds and all that, and there will be a couple in the lesson. So let's skip straight to example 2. Solve the differential equation. Okay, now remember, when you solve a differential equation, your answer is going to be y equals some expression plus c. And if you're given the initial condition, you're able to find c, but that's not the case in this problem. But what are we going to have to do first? Yeah, move that dx over to the other side, so that when I integrate, I have just y's on the left and just x's on the right. All right, and so that's how you get the y equals part. All right, so let me go ahead and rewrite this. Integral of 3 over 2 minus x dx. And we did this yesterday. We would have seen integrals like this. So do you remember what would be a good thing to let u equal in this case? The denominator. Okay, so 2 minus x. And du, the derivative of u, what would that be? Negative 1 dx, which that negative I'm going to just move to the other side, just like how I would any other number. And so my y equals turns into negative. Now, this 3 is also something we want to move to the front. It's only going to help us. And that's good because I don't see a 3 over here anyway. So we're just moving that 3 to the front. And so that becomes 1 over u du. And we talked yesterday about the integral of 1 over u du is the natural log of absolute value of u. So that's what my next step is. We just write natural log, and remember u has to be an absolute value because what you take natural log of has to be positive. All right, can I leave my answer like this though?
No.
No. We have to say, okay, what was u again? It was equal to 2 minus x, and that has to be what I write my final answer. Okay, and again, if they gave us an initial condition, we would have had to do a little bit more work to find that plus c and then rewrite the answer, but I don't have an initial condition, so we kind of get out of that step here. Okay, example 3. All right, finding f prime of x. When we're given an f of x, that's an integral. In other words, we're deriving an integral. What theorem allows us to make this an easier problem?
Second.
That's exactly right. Second fundamental theorem of calculus. Because if we don't know this theorem, then what we have to do is integrate the whole thing and then derive the whole thing. We can bypass both of those by applying this theorem, which says all we got to do is plug in the upper bound. So instead of 1 over t, we write 1 over 3x. We do have to go times the derivative of the upper bound. You do have to remember that. And just think of it kind of like chain rule, maybe, if that helps you. It's not exactly like that, but sort of. All right, so then we go minus, and now we plug in the lower bound. So instead of 1 over t, we write 1 over x times what? 1, because the derivative of x is 1. And this is totally fine for your final answer. You don't have to simplify it. But let's say this was multiple choice, and we have to simplify. Let's just say, this one's not too bad. What's 1 over 3x times 3 simplify to? 1 over x. The x is still in the denominator. All right, minus. And then this 1 over x times 1, that's just 1 over x. So what happens here? 0. If this was multiple choice, 0 would be the answer you need to find. So you don't have to simplify. I've said this many times. I just want to make sure everybody really gets that. But sometimes you do have to because it's a multiple choice problem. Okay, example 4. I know I'm going through this fast, so please ask questions if you have. All right, find the area of the indicated region, which means the area between the curve, the x-axis, bounded by 2 different x's. What does this sound like? What are they really asking us to do? we could do a Riemann sum if we wanted to approximate. We need to actually just integrate it. Okay, they don't say integrate it, but we can integrate it. But yeah, you're right. We would have done a Riemann sum before, and that would have been a good approximation. So we want to integrate, and we have some bounds here. What are we integrating from and to?
0.
From 0 to 4. Okay, so those are our bounds. Okay, and they give us the function here, 2x over x squared plus 1 dx. All right, so I would like for you guys to do this by hand, meaning without the calculator, and then I want you to get your TI-89s out and check it with the calculator. Okay, and I'm going to give you a couple of minutes to do that. Okay, so how did you guys start this problem? Found u. So u equals x squared plus 1, then du equals 2x dx. Now, in this particular problem, you have a 2x and a dx. Did you guys notice that?
Yeah.
Okay, great. Then I don't need to divide over the 2. I don't need to worry about moving that 2 to the front. So here's the thing. If you didn't notice this, you may have moved that 2 to the front, and then this may have become a 1/2. And that's okay because they cancel. So either way it should work. The only problem you have is if you took care of one of them and didn't look at the other one. Okay, anyway, we have the integral. This turns into 1 over u du. And when I integrate this and I plug in bounds, I can't use my old bounds. I got to use new bounds. Okay, so this upper limit right here, this 4, what does that turn into? 17, right? Because 4 is an x, and x squared plus 1 equal the new u, which is 17. What does the 0 turn into?
1.
A 1. Now, some of you are thinking, I didn't do that. All right? It's okay. I'm going to explain something here in a minute. Okay, hopefully you integrated as natural log of u, and then we had 17 and 1. And so you don't have to go back to x. If you've found new limits of integration, new bounds, you can just stay in u and say your answer is natural log of 17 minus natural log of 1. Okay, that's the answer. If by chance you replace this u with an x squared plus 1, well, that's okay, but then which bounds should you be using?
Wait, why is it just natural log of 17 minus natural log of 1? Because when you plug in, I'm confused.
Okay, hold on. Let me finish what I was saying here.
Okay.
For the people who, instead of u, wrote x squared plus 1, those people needed to do 0 and 4. So like what I'm saying here is if you said this was your answer, okay, then you should have been using the 4 and the 0. But look what happens when you plug in 4. Okay, you get, what's 4 squared plus 1? 17. Minus, now you plug in your lower bound, 0 squared plus 1.
Oh.
So it gets you the same answer either way.
So what's the point of...
So here's the thing. On this particular problem, I would say they were about equal. At some point, you're going to have to square the number and add 1. On some problems, especially when u is pretty complicated, it's much easier to do it the way I did here, which is go to u, stay in u. You get to do that when you have bounds. Okay, when you have the numbers, the limits of the integration from some number to some number. It doesn't really matter. The other reason we really focus on this is because remember some of those multiple choice, your new answers looked like that. So I wanted to make sure that you at least knew how to do that. Okay, but you just have to be consistent. You got to use x's or you got to use u's. All right, this is totally fine for a final answer. If this was multiple choice, what do you think they'd do with this natural log of 1?
-0.
Yeah, and so your final answer really is better off as being natural log of 17. And when we plug this into our calculator, we're going to get natural log of 17. So I'm going to go to F3 and I'm going to integrate 2x. Now when you hit divided by, remember the denominator is more complicated than just one thing. So we got to go x squared plus 1 in parentheses. Oops, plus 1. All right, and I said parentheses, but somehow I didn't do them. So there you go, like that. And then we're going to go comma x, comma 0, comma 4. So that's how you do that in the calculator. And see, we get natural log of 17. What if our answer choices are decimals? How do we get a decimal from here? The diamond enter thing. Here we go, diamond enter. And so it takes a second to calculate it. It's doing a lot of calculations. And we get 2.833. Whoops. All right, so on example 5, average value. We're experts at average value, right? 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 Okay, average value. Who knows the formula for average value?
F of C equals 1 over B minus A integral F of X, AB, F of X.
Okay, so at least one person knows the formula, maybe more. All right. If you're not good at memorizing a formula, that is okay, because if you're more like, I'm a concept person, great, this is the concept. You integrate, and you take that integral and you divide by your total time. Sometimes it's not time, but I feel like if we say that, it makes sense and you'll remember what I'm talking about here. So this is what I mean, okay? So you can over here go 1 over 50 minus 40, and you can integrate from 40 to 50 of this function. They're going to give you the function here. Okay, and you just evaluate that whole thing in your calculator. Or you can do the integral from 40 to 50. You don't have to write both of these things down, by the way. Write the one down you think is going to help you. So you can take the integral, and then what would you divide by at the end? 40 to 50, that would be 10. It works either way. Okay, you need to pick what works for you. If you can memorize a formula, memorize a formula. If you're a concept person, you got to know the concept. It's probably ideally best if you understand the concept and memorize the formula, but it is Friday anyway. All right, so we're going to plug this into our calculator. So I'm just going to go 1 over 10 times the integral, which would be F3 integrate, and then I'm just going to type in it, 90,000. So this is where it's really nice to have this calculator. 400 plus 3x. Notice that I put 400 plus 3x in parentheses. You had to do that. Comma x, comma 40, comma 50. And if you're like, I know I want my answer to be a decimal, which it makes sense in this case because we're doing average price. If you know that, just hit diamond enter from the get-go. You don't have to do enter, wait for it to do it, and then diamond enter. If you know you want a decimal, then just hit diamond enter from the get-go. And again, look right here and make sure that it looks like what you meant to type in. If you messed up with parentheses, you're going to figure it out when you look up here. All right, so that's my answer, 168.268. Now you may be thinking, is that 268? Yeah. You may be thinking, hey, this is price, so we only need to round to 2 decimal places. Okay, just always round to 3. You're never going to get counted off for being more accurate. Think about the gas station. Anyway, it's not 99 cents. You see how they have the little 9s up there? They do fractions of pennies. That's how they make more money. All right? It's not 99 cents. It's 99 cents and the 99.99% of the next cent. So, anyway. Now, we can probably assume this is in dollars, but it may be in like thousands of dollars or millions of dollars, depending on what we're doing. All right? But that's how you get it. All right? We could have done this before. All right, example 6. Okay, here's another one. I'm going to pause the recording, and I want to have you guys do A, B, and C on your own. Okay, A, B, and C, all of this was what we did last semester. It could have been on the semester exam. You shouldn't be integrating at all on A, B, and C. Okay, so what did you guys do to figure out the direction in part A?
Plug in 1.5.
For t into the velocity equation, right? So basically you found v of 1.5, which would be like 1.5 squared minus 4. You didn't have to write all this out, but I am, just so everybody knows. And what did you get for that number? Negative,
1.5.
yeah, negative 1.167. You round to 3 decimal places. Now that's great. We still haven't actually answered the question. So which direction along the x-axis? So my answer here should be right or left. Left. And my justification should be because v of 1.5 is negative. Now you're okay saying velocity is negative, but then you got to say at time equals 1.5. In your justification, you have to reference the time. I'm going to get more picky with that kind of this as we go on, closer to the AP test. Okay, for part B, acceleration. First of all, we got to just find acceleration. And how is that related to velocity? Derive it. V prime of t. How many of you used quotient rule? Anybody? How many of you used your calculator?
Oh, yeah, are you?
All right, now if you used your calculator, you get t squared plus 4 over t squared. If you used quotient rule and you simplified, you also got this.
I felt like that was the wrong answer though when I put it on the calculator. They tried it a couple of times.
Yeah. It kind of looks like it's too simple.
Yeah.
But that is it. That is the acceleration formula. So then I'm going to, again, plug in 1.5. And so you plug in 1.5 here, you get 2.778. Now, if you're like, I did all that, but I didn't get 2.778. You might have, especially if you use quotient rule, maybe you messed part of it up. Okay, but again, you get a calculator, like really use the calculator. Have the calculator find that derivative for you. All right, and so that's great. And then we move on to part C. Now remember part C, or speed, you can't just look at velocity or just look at acceleration. You have to look at both of them. Okay, so what is the answer here? Speed is, why?
Because they have different signs.
What has different signs?
The acceleration and the velocity.
Yeah, so I'm going to say V of 1.5 and A of 1.5 have opposite or different signs. Now, you could have said because the velocity and acceleration have different signs, again, you would have had to say at t equals 1.5. What if they were both negative? Would speed still be decreasing?
No.
No, speed would be increasing, and that's the part that most people get mixed up on. They think negative acceleration, negative velocity means speed's decreasing. But it really has to do with the relationship between these two numbers. Same sign, speed increasing, different sign, speed decreasing. All right. Part D. This is the new stuff. Okay, part D says, given that x of t is position of the particle at time t, and then they give us an initial condition, and then they tell us to find x of 2. All right, so the first thing we got to do is find x of t. Now, if we have velocity, and we have acceleration too, but I'm going to focus on velocity. How do you go from velocity backwards into position? You integrate. Now, you have a calculator, so this integration really shouldn't be that hard. But I'm going to take it one step further, and I'm going to do this by hand, just because I want to show you that you can, in case that this type of problem is on the non-calculator part, and I feel like I need to refresh how to do this. See how they're both just over t? You could say, well, what's t squared divided by t? That's just t. And then this would be 4 over t. And you can integrate both of these by hand. Of course you can with your calculator too. It's much easier with the calculator. Again, I'm just kind of showing you something that you might have forgotten. So that first integral is half t squared. The second one is the minus 4 just gets tagged along. The integral of 1 over t is natural log of t. And then we have our plus c. Now if you notice, I left the absolute value bars off. Why is it okay for me to do that on this problem?
Because the numbers can be negative.
What does it tell you at the top? That's a good thought, so let's
It's all
expand
greater
it.
than 0.
It's actually along those lines.
It's all greater than 0.
T is always positive because it's time.
Oh.
So if we know that T is positive, I don't have to specify it. If you put absolute value bars though, it's not wrong. It's never wrong to put them, okay? I just want you to know why I'm not putting them, and so that you don't get freaked out when you see that. All right, so that's just x of t. Now I got to use the initial condition to find c, right? And then I got to do something else at the end. So I'm going to let 5, I really should have put more space on this problem. I've got to remember that for next year. So 1/2 times 1 squared minus 4 times natural log of 1 plus c. You could do this in your calculator. You could put this in the solve feature. You guys know that. But this one really isn't that hard to do by hand either. Okay, what's natural log of 1? So that whole thing goes away. The 1 squared, that's just a 1. So really you have 5 equals 1/2 plus c. So what does just c equal to? 4.5, 4.5, 9/2. So that plus c really is plus 4.5. And so really to get to the last thing, which is what we really want to do, x of 2, okay, now we're plugging in 2 into this. And this is an acceptable final answer. That's totally fine. It's not simplified. We've been over this. You don't have to simplify it. If you wanted to, you'd type that in your calculator, you'd hit diamond enter or whatever, and you would get 3.727. Okay, I don't really want to spend more time on that. You guys know how to type that in. Okay, last thing we're going to do together. That is total distance. Remember Ellie and Trent on their bicycles on that problem that we did on the after party? And I said something about Ellie. She went to go to school on her bicycle. She said, hey, forgot my homework. She went back home. And then she's decided to keep on going to school after she got her homework. And there's the whole idea of they're comparing 2 different things in the after party. And that's why I put that one there before you see this here. Okay. If you want to know how far the particle is from where it started, okay, that's just regular integrating. You're adding, you're subtracting when you're moving backwards, it's going to find displacement. This is saying total distance, which means that whether you're moving to the right or whether you're moving to the left, you're going to add both of those. You know how like when we do integration, what happens when we have a negative underneath the x-axis? We're supposed to subtract that, right? But this is saying I don't want to subtract it, I want to actually add it. So anytime you're doing total distance, and we're going to start seeing this more often, you have to take absolute value of the whole thing. Does this look familiar at all? Doing absolute value? Should. You did it not that long ago. I mean, I get that you don't remember every tiny little thing you do in here, and that's of velocity. Okay. So the way we're going to do this in the calculator is we're going to hit the integral sign. Okay, that's going to open up parentheses. How do you get these bars? Well, that's ABS, absolute value. Where does your calculator do this? Do you remember? The catalog. The catalog key is right in the middle of the calculator, and it should pop up as the very first thing. You may have to scroll or hit the A or something, but unless you've been messing around with your catalog, it should be the very first thing. And we need to make sure that this whole thing gets put in absolute values, absolute parentheses. We're on the absolute value. So this first parenthesis is to capture all of this. I got to put an extra one in because the numerator right there needs to be its own parenthesis so that the whole thing gets divided by t, and then you close the parentheses on the absolute value. Then you get to do your comma t, comma 1, comma 2. Okay, so we did this not that long ago on that after party. All right, so that's how you type it in. Okay, I'm going to show you on the calculator right now, so it's going to actually cover it up, which I hate. Let's see, maybe I'll just move it over here. There we go. So we do F3, we integrate, go catalog ABS, put an extra parenthesis for the t squared minus 4, divided by t, close the parentheses because you're done absolute value, comma t, comma 1, comma 2. Of course, we could be using x if we wanted to. And it takes a second, and it may, if you want to make sure that it looks like what you want it to look like. Okay? And so we get 1 point, I hate that when I start writing, 1.273.